Alrighty, so welcome to the Biosecurity Earth and Space session. My name is Darcey Watson. I'm the Executive Officer of the Andy Thomas Space Foundation, and I know I've had the wonderful opportunity to meet a lot of you, but if I haven't yet, welcome to the 18th Australian Space Forum, and we really hope that you get something incredible out of this biosecurity panel. I know I certainly will, and having spoken to the panellists before this session over the past couple of weeks, I am so incredibly excited to hear everything they've got to share. Now, I know you're not here to listen to me, so I will quickly get through to our wonderful panellists, but today we're essentially looking to see where the frontier of science, ethics and innovation all intersect. In a world increasingly shaped by global connectivity and interplanetary exploration, biosecurity isn't simply about an earthbound concern anymore. So this session, we're going to delve into the profound importance of protecting our planets from threats beyond, including biological threats, contamination and environmental disruption across the board. And so, as I mentioned, I'll pass over to our wonderful panellists. First, I would love to welcome Dr. Davina White, the GIS Lead at PIRSA, to take the stage.
Thank you for the introduction, Darcey, and good afternoon, everyone. Thank you for staying for the session. So, PIRSA is the Department for Primary Industry and Regions in South Australia. We are the agency that is known as the Controller for Biosecurity in South Australia. Can I just go to the next slide? Yeah. Okay. So these are the main areas that PIRSA has responsibility for, ranging from animal and plant health through to the aquatics, weeds, pests and animals, and most of you will be familiar with the fruit fly. So I'll focus today on two areas. Fruit fly will be one, and the other one, a more recent event, the far northeast flood in South Australia. This was an opportunity in my role to use some different types of imagery. My team, that I'll acknowledge as well, did some of the work here. I was the one leading them on. And one thing that came to light quite early on in the incident was that historical data is very important. So a flood of the extent that we were going to experience, that we knew was on the cards, was the 1974 flood. We went to look back at the archive, and there was one cloud-free image that covered most of the area of interest. So we were able to explore that with some normalised difference water index because of the limited wave bands available with that particular satellite. That far back in time, we were able to estimate a flood extent from that, and we were able to provide that as a supporting agency to the SES, who were the lead agency in this particular response. And also Department of Environment and Water were providing the flood predictions. So that 1974 flood extent helped to inform the flood predictions, along with the peak flood events that had happened from 2019 onwards. Along with that, obviously, we've got the more recent Sentinel imagery, where there was the modified normalised difference water index used, and also now available, that was mentioned in one of the talks earlier today, the ISIGHT and SAR satellite and Sentinel data to help improve that flood extent estimate. In terms of what PIRSA's role was in this event, obviously there's a number of cattle stations in that area. So it was that regional planning and support to those locations, and in Amika in particular, township was impacted. And also the animal welfare and support, where animals could be moved to higher ground, how much essential fodder was required in certain areas, support with logistics, and also that post-recovery and impact assessment. So the first image here that you're seeing is that 1974 flood extent estimate with the predicted flood estimate for the area. So that was like the first synoptic view we had of how many stations were likely to be impacted, and that really helped with the early stages of planning and support for those areas. And then the second slide here, we're looking at a more recent Sentinel image that provided a good estimate of where the flood extent was at that particular point in time in April. And then moving on to how that event unfolded, you can see that the predictions were actually quite accurate in a number of places, so it did help support the efforts and respond more quickly because of that. And also the filling of Lake Eyre, as you can see there, that happened over time. Some of the other data sets that we had, I could only display certain data sets because some of them have obviously got some sensitivity to them. We had the extents of fence lines, for example, and could estimate how many fence lines have been damaged, so then provisions could be made to help with that recovery effort. From a biosecurity perspective, there'll be more follow-up work conducted. In particular, that monitoring of the flood extent and the recession of the flood extent in relation to an example, and they are examples. I'm not saying that any of these are actually occurring yet as a result of this flood extent, but they're concerns that we have that are being monitored at the moment. So in terms of the cane toads from the 2010 to 2011 floods, there was a movement of cane toads as a result of that from the Thompson River further south down the Cooper Basin area. So there'll be a monitoring of that recession, because where there is that recession, there's an increase in breeding ground for those animals. So there'll be some monitoring, more targeted monitoring that the imagery can support. Along with that is identifying areas that might be of high risk from other potential biosecurity risks. Japanese encephalitis can be, obviously, mosquitoes are one way it can be transmitted. Where there's moist areas and more grass, for example, there's a higher risk. So we'll be able to provide intelligence for that. But also, pigs are a transmitter of Japanese encephalitis, and knowing those areas where they're more prone to be inhabiting post-flood would also be monitored as well. And then obviously that increase of weeds invading South Australia as well. So there's a number of avenues where the imagery will be used to monitor those situations. And then moving on to fruit fly outbreaks in South Australia. I've got images here of the two main types of fruit fly of concern. The one in the top right corner there is the Queensland fruit fly, which is more prevalent. Notable, it's slightly larger with those white markings. The bottom right there is the Mediterranean fruit fly. It's a smaller size and rounder in shape. And the bottom there, this would really put you off eating peaches, so sorry about that. But peaches is one of their favourite fruit. But that shows you some of the maggots there in a peach. So obviously this is what we're trying to avoid, and just providing a bit of public information around what to look for as well is always useful. So I'm playing my role there. So following on from that, some of the information that my team provides to support the fruit fly response, and it's many and varied, is land use and cadastre data, geospatial analytics to support the planning and operation team on the ground, so logistics on where they can focus their efforts, be more targeted, but also providing intelligence around how successful that baiting and hygiene has been. There's a vast array of information that we provide. In terms of space data in particular, we've been doing some recent work looking at Landsat imagery to monitor or identify locations where there might be overwintering of fruit fly, where we're getting those increased detections of fruit fly, and does that correspond with warmer locations, and does that warrant further investigation on the ground? And also identifying those host fruit trees with high resolution imagery as well. And then we have an entomologist with expertise in fruit fly behaviour, and we obviously that all feeds into the understanding of what's happening. So you can actually go online to find this information to see where all the latest outbreaks are in South Australia and all the outbreak areas where quarantine is. We've had metropolitan outbreaks as well as Satsgalind, Salisbury North, you see there. Obviously the Riverland's been prevalent and has been a focus of attention. We also had a Seduna outbreak that was more isolated that came in from Western Australia. In terms of some of the work we've done with the thermal imagery, we've mainly focused on Landsat, although we are going to look into Sentinel imagery as well. This has been used to identify where those warm locations are. Adult fruit flies can actually reduce their metabolic rate and survive in colder temperatures where there's those warmer patches. So this is why we're looking into this in more detail. You may be aware of sterile insect technology that's released either from a fixed-wing aircraft or on the ground that's quite targeted. The sterile fruit flies are effective in reducing the population of fertile fruit flies, basically, without getting into too much biology, but that's basically how it works. And then, obviously, this information can then be used to do more targeted on-ground operations as well. So this is an example image. Obviously, this is relative temperature. One of the more recent images we've got from the 9th of June. You can see where there are locations, and I've had to desensitise this information a bit, so I can't give you too much away, but there are certain locations there that are being investigated in further detail and might inform well, we are doing some more detailed on-ground operations on those sites, and there may well be some more traps going out to provide some further detail. So we have specific traps for capturing the fruit fly, and also there may be some additional sterile insect technology drops over those areas as well. And then I was also asked to include in my presentation how space data supports my job, many and varied, and I'm glad I work in this sector because it's made me, how can I put it, use the applications of this type of data more effectively and inform people in this particular department how we can use it more effectively, and I've been quite passionate about doing that. Some of the ways in which that's worked has been in those early stages of monitoring an incident. Obviously, when you've got that synoptic over the landscape, it really assists in those initial stages of understanding the extent of the situation and those first response and planning support scenarios. Then providing support intelligence during the actual response itself, like I say, specific metrics on damage to assets is one example. Assisting the planning and operations teams, as I say, with decision support, and bringing in those multiple spatial data sets as well to provide a fuller picture and stronger evidence to make more sound decisions. And then that management, mitigation and eradication, which is the aim of the fruit fly. They do have an eradication plan. So being able to look back at the historical trends with the archived imagery, looking at the current synoptic, and we're even using specific analytics such as space-time cubes to do some predictive modelling on where the next hotspots are likely to be, and that has actually been quite accurate. And also some of the more recent work that's happening is around using some very high resolution imagery to look at compliance efficiencies for the aquaculture industry. And at the moment, it involves people going out in vessels, and we think we can do it all on desktop with high-resolution satellite imagery. So that's an area that we're looking into. And also with the, as everyone would be aware, the harmful algal bloom. We're looking into image captures there to support monitoring that situation and to provide more detailed information, again, to support fisheries and aquaculture industries. So thank you for your time and ready for questions. Yeah.
Amazing. Thank you, Dr. White. So we'll have our next presenter up in just a second, so please feel free to take a seat. Can I just ask of everyone in the space industry in this room, how often, or raise your hand if you've ever been asked why space? Why do we invest in space? I know I certainly have been asked that many, many times, and this is the exact reason why. There are so many, I mean, while some of the data was, of course, desensitised, but there were so many properties there that are involved in agriculture or mining or whatever else it might be, which are fundamental to the economic backbone of Australia. And so this is why space is so fundamental. It's all of the end users that we don't even necessarily think of on the daily basis that are using space to make informed decisions and well, prevent disaster and really support us as a growing country, industry and economy as well. Now we've heard a bit about the ground side, now we're going to look a little bit different, and I'd love to welcome Kiara Wilson, the Acting Director at the Department of Agriculture, Fisheries and Forestry, who will take us on a little bit of a different journey, looking at some samples returning from outer space. So Kiara, please welcome.
Hi everyone. I was so captivated by that last presentation, I've almost forgotten my own speech, so bear with me. So I work in the Department of Agriculture, Fisheries and Forestry in the Biosecurity Animal Division. When I was thinking about this speech and space, I was thinking that biosecurity probably isn't one of the first things you think of when we're looking at space. So my aim for today is that if you're thinking about stuff coming back from space into Australia, to get you guys to think about biosecurity a bit more. Can we do that? Yep, awesome. All right, I'm gonna figure out this. Okay, so I work in the Animal and Biological Imports branch. We probably would have seen the show Border Security on TV. If you've come back from overseas and you would have filled out an incoming passenger card and gone through biosecurity, you would have seen our detector dogs. Those are our frontline workers. So they're biosecurity officers just like we are. So what they're doing is regulating biosecurity risk. So they're looking for goods that contain biological material that could carry or be contaminated with pests and diseases that we don't have here in Australia. So like I mentioned there, the front line, what we do is we assess permit applications. So when we require a permit for something to come into Australia, whether that's sea freight, air freight, or from space, we're doing those technical assessments for those import permits. We also develop import conditions, which is what you'd see the border security staff assessing those goods against. The other thing that we do is we respond to emerging animal disease outbreaks when they occur internationally. So why are import permits so important? I just wanted to highlight this. So you've probably heard that Australia has some of the strictest biosecurity requirements in the world, and it is true. We are an island, we have no land borders, and so we are protected from a lot of the pests and diseases that they have in other countries. So we try really hard to prevent them from coming into the country. Even more importantly, we want to stop them from spreading to our agricultural and farming areas. I've listed a few, I've listed a few animal diseases up there, and if we had an outbreak of any single one of those, it would cost our country billions of dollars, and it would be devastating for our agricultural farmers. So we do permits because they allow us to assess biosecurity risk before these things come to the border, right? So we can apply import permit conditions to manage that biosecurity risk to an appropriate level of protection. So what that means is that we understand and we accept that the biosecurity risk will never be zero, but we want it to be to a level that we are comfortable with it coming into the country. So now that hopefully I've got you hooked on biosecurity, yay, I'm going to bore you with legislation for just 10 seconds. So we work under the Biosecurity Act 2015, and under that is our biosecurity conditionally non-prohibited goods determination. That basically means that it's a list of alternative conditions, and if you can meet those conditions, then an import permit is not required. So I've got a snippet from, I'm going to call it the GD for short. So I've got a snippet from the GD up there for noodles. We all know noodles. I was probably a bit too familiar when I was at uni, but the conditions for that are that the goods are shelf stable for instant use and for personal use. So if you can meet those conditions, then an import permit is not required. It doesn't matter if it's coming from Madagascar or from Mars, you don't require an import permit. If you can't meet a single one of those conditions, or if your goods, whatever it might be, aren't listed in the GD, then you need an import permit. If none of that made sense, that's okay. We put all of that information into our website, Bicon, where you can search for import permit conditions. This is what Bicon looks like. So I just mentioned that you can search for conditions in there. You can also apply for a permit in there if you need to. So you can see there's a quick search bar up there, what you'd want to be doing. It was really exciting that Peter talked about this just before with researchers importing things into Australia, capsules into South Australia. So you'd actually type what the goods are that you're wanting to bring in. So if you're bringing things in from space, you probably don't want to type space. It won't come up with anything useful. If it's, like animal fluids and tissues, so they were talking about the research sort of aspect, or it might be antibodies or antigens, that's what you would type in there. If it was like a monkey that you were sending up to space, you'd search for like monkeys or live animals. If it's, an astronaut going up and they have some snacks, obviously, and there's like biscuits coming back down with you, you'd search for biscuits. But I'd recommend doing that before you go up because you might not have very good reception. If you need any help or have any questions, you can contact us through our biosecurity import support team through imports@af.gov.au, or you can call us at 1800 900 090 and they will take it through you step by step. So we've talked about why it's important, if you need a permit, how you would apply for a permit, but then once it gets to us, we want to look at what we actually need to assess the biosecurity risk. So I've got a list of things up here. We might be looking at a few of these or all of these. So the first one is biological material. So if it contains biological material, if it's like animal, plant or microbial, we'd look at the genus and species. We also might look at the country where it's coming from and the disease status of that country. We'd look at the end use of the goods. So I mentioned before that we don't want it getting to our agricultural lands. So if, for example, you got samples from space and you were bringing them into a lab for research purposes, that's a much lower biosecurity risk than if you are taking those into a field for experimental research. The volume, if you have a larger volume, it's more likely to be exposed to animals than a smaller volume. The packaging itself, so if you're taking a capsule up to space, you're opening it up and collecting samples, there's a higher risk of contamination than if that capsule remains sealed for its entire flight. We look at the country that the spacecraft took up from and the disease status of that country. Approved arrangements you might not have heard of before, but this is a way that we manage biosecurity risk onshore here in Australia. So these are third-party facilities that are like laboratories, or it might be a processing facility or a storage facility, and they enter voluntary arrangements with the department so we can go audit them and we have oversight of those. So if you have access to one of them, they're a way that we can manage that risk onshore. And special arrangements. Obviously, we know that things from space are quite unique, so if there's anything else about your spacecraft or capsule that we need to know, please let us know. So it might be that it needs to land in a certain area or whatever it might be, and we'll work with you because it might be able to manage biosecurity risk. Something I just did want to note was that this is very much an emerging area for us. We have limited policy advice at the moment. We've only had one permit application, which I'll touch on in a moment. So our advice at the moment, things we really want to highlight, is that even if your goods are leaving from Australia, going to space and coming back, you might still require an import permit. If you are taking samples from space and bringing them into Australia, you might still require an import permit. Because it is so new and we're developing this policy and everything, if you can get in touch with us as early as possible, that would be fantastic. So Peter mentioned this one before, so this is my example, not because it's my only example, but this was Varda Space Industries and Southern Launch got a permit for their Winnebago 2 mission, which you probably have heard about. So this was launched as part of the Transporter 12 rideshare mission with SpaceX on the 14th of January. It was the first commercial space return to Australian soil, which was really exciting. So they contacted us, they applied for an import permit, and we were able to work together. So their mission was obviously space and our mission is biosecurity. And we were both able to accomplish those because this landed in the Coonabah Test Range in South Australia on the 27th of February this year, and they made history, so that was really exciting for us and really exciting for them. This is a picture of it in case you haven't seen it yet, but that was it landing in South Australia, and this is what Peter was just talking about before, and we had permission from Varda to talk about this today, so thank you to them. But I will leave it there. Thank you so much.
Now, I understand that we don't have too much time left before afternoon tea, but what I might do is if I can get our two panellists up, I just want to ask you both one sort of quick question, or unless anyone from the audience has one, I don't want to take an opportunity away from you. Oh, we do have one. We have one right at the back. Kath Roberts.
Just a question on the space biosecurity, and I know the Varda mission, absolutely fantastic. I really thought you had to apply for people permit, but what about space junk? Because Starlab landed in Australia many years ago. What happens when, or could there be biosecurity risks from the other junk that has sort of landed in Australia?
Yeah, wait. Can you hear me now? Yep, you can. That's a really good question. So when there is no importer associated with the goods, so usually we're dealing with, so for context, I work in the laboratory and laboratory and human tissues team. So we're usually dealing with importers who want to research things in Australia. If anything enters the country and there's no one associated with it, we do have to assess the biosecurity risk with those goods. So it could undergo sampling or testing, but generally we'd have to destroy it, or it would go for deep burial or incineration. If we could do something like irradiation with it, then we would consider that. If people were interested in actually using it, like if a researcher wanted it, then there are other treatment methods that we might be able to consider. Yeah.
Wonderful. Any other questions from the audience? Now, our two panellists will be available briefly after this to answer any questions one-on-one, but I might just quickly ask you, and this is not one that was on my list, but just because we don't have much time, I wanted to just ask you, what have you found to be the biggest benefit or challenge of space as part of your individual approaches to biosecurity? Obviously, we've seen that it comes from things that are affecting life here on Earth, and also what life outside, if there were some, who knows, could potentially do to Earth as well. So just, biggest benefit or challenge that space has posed to your individual sort of day-to-day jobs.
Right, everyone can hear me, good. I would say that it's showing the evidence. I think that you can, they say a picture says 1,000 words, but it's the metrics behind it that people often want to see, so they can know that they've got sound evidence to base their decisions on. So I think it's important to work towards products that can provide that in a quick way. I mean, some of those methods that you would have seen up on the screen there were done in a very quick and short response scenario. So we often, in those emergency situations, need to get products out very quickly. So it's being able, I guess one of the challenges is being able to respond quickly, to get a hold of the data as quickly as possible is really important. I'm grateful for what data is available that we can use. I think having greater access and speedier access to projects that we can quickly assess is really important. I would say that would be my comment there.
Wonderful, thank you. Kiara?
One of my biggest challenges was, so usually when we issue import permits, we have a country of export, and we didn't have a button for space. It turns out that we can just put the place where it's actually the spacecraft is taken off from on the permit. So that was an interesting challenge for me. But on a serious note, one of our biggest challenges, which is also my exciting thing, is that because of those special arrangements that I kind of talked about, it makes us think about biosecurity in a different way. So usually what we've traditionally been dealing with is like trade, so things are coming via sea freight, they're always coming to a port, or via air freight and it's coming through the mail, or passengers are coming through the airport. And with space, we're having them land like in fields and things like that, and so yeah, just getting us to think about biosecurity in a different way and thinking like, can that actually manage the risk because it's going into like an airfield or something where there's no cattle, they clearly don't want them there, or is it a risk still because, you know, if like birds fly down or something, they could still access it. So I think that's been a challenge, but really interesting for us to think about.
Incredible. Thank you both so much. And we will wrap it up there just so that you get an opportunity ahead of the next session, which commences at 3:45 in Hall L. So that's the end of streams for the day. Can I have a huge round of applause for our panellists, Dr. Davina and also Kiara. Thank you. Now, I truly do think that if we could get to the bottom of what you actually both do in a day, we would be here for several weeks having this conference. So please do, everyone, if you have any extra questions, come up and ask our panellists. Otherwise, go and grab some afternoon tea, and we'll see you at 3:45 in Hall L.